So H2O4All, that is innovative integrated tools and technologies to protect and treat drinking water from DBPs. It's an European project that is led by the University of Coimbra, and it is composed by 18 partners from several countries with the main aim of understanding and monitoring disinfection byproducts and their spread through the drinking water distribution systems, develop breakthrough water treatments to remove DBPs or avoid their formation during water disinfection processes, deploying these new technologies to try to avoid the spreading of the DBPs into the drinking water system by paying attention, of course, on the life cycle analysis and costs and risks of these new technologies, to be sure that we are proposing new technologies that have a lower impact, social, environmental, economical impact, and those that are now being applied into drinking water treatment plants nowadays. And also the aim is to establish preventive measures for water quality, to ensure water quality at different levels. These recommendations on prevention levels involve the general public. I mean, we want to understand which are the behaviors that we can have, every one of us at our houses, in order to safeguard water quality in all its cycle, but also involving the stakeholders, the technology developers, the water utilities, and also the policy makers, in order to reach policies that are more strict regarding the water quality, but also that they are feasible, that we have technologies that are able to achieve the goals established on those policies. So this is a short of overview on the project. The project is led, as I said, by the University of Coimbra. It is composed by 18 partners from 10 countries around Europe. So we have the know-how from several research groups and also several companies from all around Europe. And we have a pilot site, so all these technologies that we are developing, either for the monitoring of the DBPs and the water quality, and also the water treatment technologies, were validated. I mean, they were developed at the lab scale, but then they were validated in the pilot site. In this case, the pilot site is from H2O, our partner, that is the water utility here in the city of Coimbra, where the quality of the water is really good, but we want to prepare ourselves for the future, because as we all know, water disinfection is crucial for the safeguarding of the water quality and to provide safe drinking water and avoid waterborne diseases. But the thing is that the increasing on the water pollution due to the mankind pollutants that are discharged to the natural water sources, but also the exacerbation of the climate change and the climate change events regarding droughts and also and also excess of rain is leading to a decrease on the water sources quality, which means that in the near future we will need to further improve the water treatment processes, which will be related with the increase on the loads of disinfection agents that will be applied in these water treatment systems. And of course, these will lead to the formation of more DBPs, with more disinfection byproducts that are produced from the reaction from the disinfectant, in this case chlorine, with organic matter into water. The disinfection byproducts are molecules that can have serious human health impact. This is still not very well understood, but H2OforAll gave a high effort on understanding the impact of these compounds on the human health and also on the ecosystem's health. These DBPs are not easy to monitor because they have low concentrations, usually in the water, and their physical chemical properties are not amenable to their continuous and online monitoring. So that's why it's very important the work that was done within the framework of H2O4All, that was the development of monitoring technologies able to be applied online, that are able to follow the water quality online directly in the drinking water distribution system, without the need of grabbing the samples and processing the samples in the laboratory. But also another important point that was achieved with this project is the fact that a tool was developed, that is the DBP Finder, a tool that where we can introduce the distribution network, the characteristics of that drinking water distribution network, and with the water quality parameters that are easy to monitor, let's say temperature, chlorine, dissolved oxygen, conductivity of the water. This online tool is able to predict, based on the predictive models, is able to predict hotspots in the network where is more likely to have the production of DBPs. So this will allow us, or will allow the water utilities to identify the hotspots within the drinking water system, where the placement of sensing systems to monitor the water quality is more interesting. So this way reducing the costs associated with the monitoring. Another important point of this project was the development of new disinfection strategies. These new disinfection strategies involve the use of chlorine in an intermittent way. I mean, we will not need to use all the chlorine that is required for the disinfection, because the combination of chlorine with UV systems is able to reach the desirable disinfection of the water. But also we developed several strategies involving several types of materials and several types of technologies involving adsorption, but also advanced oxidation systems that are able to remove the disinfection byproducts from the water if they are anyway produced. I would like to say that also it's always important to evaluate the feasibility of these new technologies, considering their life cycle assessment, and our conclusions were that there is no higher impact when these technologies are applied into distribution in the current, let's say, drinking water treatment systems, and there is even an improvement on the LCA and LCC and the environmental impact when a new functional unit is used for the life cycle analysis, that is the water quality and the removal of the DBPs by these technologies. An important point also in these projects, that is also a big achievement and an important milestone, was the interaction that we had along the project with the stakeholders, with the researchers, with the water utilities, with the policymakers from all around the world. I would say that from more than 40 countries, with different perspectives, with different water management strategies, with different water sources, with different problems associated with the DBPs, and that allow us to reach a huge report, a huge recommendation on prevention measures report, where we establish some measures that can be applied in every stage of the water distribution, from the source until the tap, to avoid and manage in a safe way the DBP, safeguarding the human health. Another important point is also the public engagement, of course. It's important to be sure that people can understand the problematic around the water quality and what we can do at our houses to improve water quality and to avoid the deterioration of the water quality. So there were several public engagement activities, and from those public engagement activities we developed an application that can be applied by everyone in order to understand the behaviors that we can use in our houses to reduce our impact into water quality, and also educational kit that was developed within the framework of this project. This educational kit is more devoted to children, to students, in order to involve them in this problematic of the water quality. Lastly, but not least, is that there was a huge lack of information about the human health and ecological impact of the DBPs, which was somehow culminated by H2OforAll, because we were able to rank the known DBPs by their potential impact on the human health based on the literature review. But for the most, let's say, the top ranked DBPs, we also evaluated their toxicity and cytotoxicity, and this data is very important for future regulations, because indeed what we found out is that most likely the currently regulated DBPs are not those that are more impactful in the human health.